Hi students, today we are going to start something which is called as tautomerism or desmotropism. Tautomerism means the type of isomerism on which a substance exists in two readily interconvertible different structures leading to the dynamic equilibrium is known as tautomerism, and different forms are called tautomers. Tautomers. Yes, the type of isomerism in which a substance exists two readily interconvertible different structures leads to dynamic equilibrium is known as tautomerism, and different forms are called tautomers. Okay, let's see an example for tautomerism. Here I am taking one molecule, acetaldehyde CH3 C double bond H. In this molecule, carbon having the double bond with oxygen and CH2. So the carbon hybridization in the C double bond O is the sp2, and adjacent carbon undergoes sp3 carbon. In this sp3 carbon is the alpha carbon. Alpha carbon contain hydrogens is the alpha carbon contain hydrogens is the alpha hydrogens. Let's see example for tautomerism. Let's try to understand the what is the tautomerism. Yes, I am taking example. See, CH3 C double bond O H acetaldehyde. So acetaldehyde has one three alpha hydrogen, and this leads to form CH2 double bond COH H. Yes. Here the migration of hydrogen atom from the polyvalent atoms into polyvalent oxygen takes place. This bond leads the formation of this isomer. It is a keto form. It is a enol form. Yes. Bond shifting happens in tautomerism. Tautomerism is called as desmotropism. Yes, desmotropism is a Greek word. Desmo means bond, tropism means shifting. It means bond shifting. Yes. Let us take next example for tautomerism. Yes, this, see, CH3 C double bond O CH3, and dynamic equilibrium, it gives CH2 double bond COH and CH3. See, in these molecules are having two alpha carbons. Yes, two alpha carbons. See, which is involved, any one of carbon hydrogens involved during the tautomerism. Yes, in this hydrogen, see, hydrogen leaves in the form of H plus. This bond is shifted to carbon, and hydrogen leaves and moves to more electronegative atom to form a alcohol. So it is a keto form, it is a enol form. So this equilibrium is a keto-enol tautomerism. Keto-enol tautomerism. Keto-enol tautomerism. Yes, keto-enol tautomerism. So let's go to few example. Let me which is exhibit tautomerism, which compound does not exhibit tautomerism. Yes, how to decide. Before telling about this, you should keep two things in our mind. Yes, two things. The first thing is the compound should have electronegative atom. The compound should have electronegative atom bonded to multiple bond. This is the first condition. Let's on the second thing, the compound should have at least one acidic hydrogen atom present on alpha carbon of the molecule. See, what is the first thing? Compound should have electronegative atom bonded to multiple bond. Second thing is compound should have at least one acidic hydrogen, means alpha hydrogen in the molecule. Yes, let's take example. Which compound exhibit isomerism, which compound does not exhibit the isomerism. Yes, CH3 C double bond O H. Yes, it has how many alpha hydrogens? 3 alpha hydrogen. Yes, it show tautomerism. Yes. Next, second one CH3 C double bond O CH3. How many alpha hydrogens are there? 2 alpha carbon, 6 alpha hydrogens. Show tautomerism. Yes. Next example, CH3 C double bond O H. How many alpha hydrogens are there? Only 1 alpha hydrogen. This molecule also shows tautomerism. Yes. Next molecule, H C double bond H. Here there is no alpha carbon, there is no alpha hydrogen, so not exhibit tautomerism. No tautomerism. Yes. Next example, C. Here how many alpha hydrogens are there? There is no alpha hydrogens. The compound does not exhibit tautomerism. Yes. Let's take next example. Look at this example. How many alpha hydrogens are there? So here alpha carbon is there. It has 3 hydrogen. So 3 alpha hydrogen. This can be shows tautomerism. It is a what? Acetophenone. Let's move next example. pH, C double bond O, CH2, C double bond O, pH. So in this molecule, which is alpha carbon, this is alpha carbon, it contains 2 alpha hydrogens. 2 alpha hydrogen means it shows tautomerism, tautomerism. Yes. Let's move on. Next example. Look at this. How many alpha carbons are present? How many alpha carbons? 2 alpha carbons. How many alpha hydrogens? 4 alpha hydrogens. 4 alpha hydrogen means shows tautomerism. Yes. Next. See the next compound. Yes, alpha carbon. Yes, how many alpha carbons are there? 2 alpha carbons. Yes. It can shows tautomerism. Yes. These are the examples of tautomerism. Yes. Let us discuss some of important points about tautomerism. Yes. Write on note. Tautomers are also functional isomers. Taking first point, tautomers are also functional isomers, exist in dynamic equilibrium. Yes. Second point, by shifting of hydrogen atom, pi bond also change its position. See, by shifting of hydrogen atom, pi bond also change its position. Yes. Next, tautomer always exist in dynamic equilibrium. Tautomers always exist in dynamic equilibrium. Yes. Next point, number of electrons and lone pairs in both tautomers always remains same. See, number of electrons and lone pairs in both tautomers always remain same. Yes. Right. The process can be catalyzed by acid as well as bases. Yes. The process can be catalyzed by acid as well as base. Yes. These are the important points about tautomerism. Yes. Okay. Let's move on. Once again, we can see the tautomerism definition. Yes. Yes, tautomerism. Tautomerism means it is readily interconvertible. Yes, it is readily interconvertible. Different structures, different structures. Same molecular formula, same molecular formula. Yes, these different forms are called tautomers. Okay, here what happened? The migration of hydrogen atom from polyvalent atoms to the polyvalent oxygen atom takes place. This bond turns to leads the two forms to give isomers. These isomers are called tautomerism. Tautomerism. Yes, it is also known as desmotropism. It is also known as desmotropism. Okay. Thank you.